guys. We have one more minute, but we'll take this initial minute to check if our audio is good. I can see a few questions already popping in. I can also click on them. First of all, welcome to this webcast. About the trial license thing. I'm not ended the previous session, and you guys want to know if you can get the trial license now, or you want to attend this and you want to know what is the process further. So those who are attending this session for the first time today, halfway through you will see a poll, and this poll is going to help you give us your choice of whether you want a trial license or you want a discussion with us, or you have any other queries on the topics that have been discussed. Choose your option, and if you are requested for a trial license, our local partners will get in touch with you and help you in processing the license. Flag if there is any problem in getting it, feel free to email to us. We will expedite it for you. Thank you. So we are almost there on time. 11. So let's start. Once again, welcome to this webcast. I'm Kapil Gaitonde. I am the technical manager for simulation products. I'm based in Singapore, and I'm covering all the South Asian countries, Australia and New Zealand for simulation products. Last few sessions I had an opportunity to see how simulation standard works. We also saw flow simulation. And today we are going into one more module of simulation, which is called as simulation professional. There's many more capabilities than what we are going to discuss today. But today my concentration would be on optimization, thermal and frequency analysis. So let's have a look at it. As usual, the panel is open. Feel free to use it to ask any questions or anything that you want to do. If anyone has missed the pre-sessions and want to have a look at it or want to hear it, feel free to email to us. We can share the online links where these content have been stored, and that should help you. Yeah. So let's move on. Simulation professional. So we already had a look of the different modules that we have, which is one of them is specializing in FEA, that is for simulation. We also have CFD, plastic injection, and kinematic analysis capabilities. We also had a good discussion on how these are coupled with each other, how they are integrated into SolidWorks CAD, and through the way I am showing you the image, you should have seen how easy it is, how intuitive it is. Of course, it is equally powerful and robust. For simulation, FEA, and to be more specific, the modules that we are going to discuss today, which is optimization, thermal and frequencies. So these would be the modules that we'll be discussing today in more detail. And let's start off directly with thermal. Before optimization, I would like to go into thermal. So what exactly this module can do, or what is the capability of this particular module? So it would be as simple as what we call as thermal state analysis, wherein I have a setup, a product or an assembly where there are different components. The one that you see on the screen here is of a PCB layout. And there are multiple chips which are creating heat or sources. There we have with different thermal conductivity. So typically the heat would flow through conduction through this part. There will also be convection. So when it comes to structural analysis, convection is treated using the constant of coefficient of thermal convection. We will give this value to the software, and if necessary or if you want, you can also simulate radiation between two surfaces. It could be a basic thermal study wherein you are understanding temperature distributions on a part. You want to understand the effect of using different materials of different conductivity, or the effect of convection on the assembly or the minimum temperature. All things can be understood and analyzed using this particular simple thermal analysis. The transient or thermal time dependent. Or here I might want to understand the effect of temperature or for a period of time. Now it could be a case wherein I want to understand after how much time the part will reach a certain temperature, or after how much time the cell would reach steady state. And either I want to change certain heat source, stop a certain heat source, or any of such manipulations can be done. Or it could be just a understanding of the time required to reach a certain kind of state. So, kind of time dependent effect, the temperatures are varying over a period of time, and to study how they vary, we have the thermal transient analysis. Thermal, the most important thing or which can affect in a bigger way could be thermal stresses. Typically, whenever a part or a assembly is subjected to change in temperature, it will either expand or compress. So when the temperature goes up, it tries to expand. When it expands, there are high chances of stresses coming at different locations, and this can lead to failures which are not desirable. So on thermal analysis, typically we take the temperatures to a structural or stress analysis and see the effect of temperature change on the assembly. These could be seen as the basic capabilities of temperature analysis. So it could temperature changes, heat transfers. If you want to design thermostats, the timing of thermostats, those can be done. And after the thermal stresses, out of contraction or expansion that may be happening can be understood. First capability is more towards thermal, and it could be convection, radiation. It could be dependent. It could be thermal stresses. All those things can be understood and simulated using this particular module. Look at the frequency module. Can understand the natural frequencies. Now, in one way, this is a bit difficult application to explain. But if I take the example or the animation that you are seeing on the screen, where is a cutter which is cutting the wood, it can happen that, or has rather, the particular cutter has multiple teeth, and these teeth are hitting the wood at a certain frequency. A certain frequency at which it is hitting the wood, there is a certain frequency at which it is hitting the motor is rotating. So obviously, any component which is around this particular structure and being subjected to that frequency can resonate, or it can lead to a huge amount of vibrations or noise. As a designer, I want to avoid those particular vibrations. Now, using this frequency analysis, I can do the analysis of different parts or a particular part which is coming in this particular setup, understand the natural frequency. Typically, a scenario could be something like this, where mode 1, the mode shape as that shown on screen, I get a frequency of 1710. Mode 2, and we might also have mode 3 as well. Knowing the motor speed or the frequency at which this particular motor is rotating, which is 1750 RPM, obviously the first frequency, which is 1710, is quite close, and that is what can hamper this particular design. Even the difference is 40 RPM, it is comparatively close, and want to avoid this killer frequency. Now, 1750 RPM could be either same direction or few other intricacies come into picture, but if I see it in plain language, or if I see it in a basic thought, the idea would be this particular natural frequency of 1710 should not be anywhere near frequency, and it is 1750 RPM. Here we might also want to understand at what frequency the cutter is cutting, that is the frequency at which the different blades are hitting the wood could also create the complications. Or frequency analysis, we can get a grasp of these topics and we can do further detailed analysis. In professional, we understand only two things. That is, one is the natural frequency, and second one is more towards the resonance. So resonance, natural frequency is more shape, and if at all you are interested, you can also get a feel of mass participation factor. Any pre-related natural frequency effects can be understood. The third module that we'll have a look today is optimization. So module, as you saw, we have thermal, frequency, static, and a few other different modules. Using this module, we can tell the software to optimize on a certain parameter. Now, this could be a case wherein I want to optimize on the mass, that is, I want to reduce the overall mass of the body. However, when I do that, I need to keep certain things into consideration. So typically for the software, we are telling it the variables, the parameters that we are going to change, telling what is the worst case scenario. For example, in this case, it is basically an LED housing, and I'm sure the temperatures do not cross a certain limit. I want to design how many number of pins are required, at what distance, what should be the thickness, etc. So all those finer details need to be understood and conveyed. What is the goal or the final aim wherein I want to reduce the overall mass. So I can give these parameters to the software. Being a parametric model in CAD itself, it can directly talk to SOLIDWORKS and do the appropriate manipulations without loss of geometry. Once it does the optimization, there is a good algorithm which can do the optimization. We get final geometry which can directly convert it into drawings. If you can do any rounding off of the numbers to have for manufacturability or of the components, and you are ready to go. This is the optimization module can work or works. We'll have a look at this module in the software once more in detail. So there are the few modules, or these are three modules that we'll see how they work in the software, and once that is done, we'll move to details. So open the software here. In the file, I would like to highlight, you should be able to see a polling window by now. This particular polling window should help you give us your choice of either the evaluation license, or if you want to talk to us, or if you have any further queries or suggestions or feedbacks for us. Okay, so let's move on. Once you have the evaluation license and you want different things, and if it is specific to what I'm discussing today, then I would suggest once you have activated simulation from tools, or you should be able to see it under SolidWorks side in simulation. Once activated that, get to help, solution, and tutorial. Okay, location which should be able to help you learn most of the things. Now, simulation in SolidWorks Premium, if you scroll down, you'll see something called as design studies. Okay, the example that I have taken today is that of this particular design optimization knob. Okay, the particular knob which you see on the screen, this is what I'm going to show you. I mentioned, like, I'll not be going in deep into each of these steps. I'm going to close this window and use only SolidWorks to show the different steps. But you can, I'm following almost the similar steps as those given here. However, when you have the software and when you are doing the trial, you should be able to follow each one of these steps in detail. This is one example which I'll be taking up. The other examples would be from simulation professional module. When you click that particular thing, when you scroll down, you'll see the first one under thermal, which is thermal analysis. So this would be one of the examples that we'll be doing today. Okay. Example would be on frequency, and that is under, again, the simulation professional, frequency buckling. The first example here, frequency analysis. These would be the three examples. As I mentioned in the previous studies, please have a look at this path. Okay, have a look at this path. typically will be in the installation directory, C drive, program files, SolidWorks Corporation. Okay, so to find that path somewhere over here, because it's in the installation directory, and there can be some certain companies where you don't have permission at these locations. The way out would be just select those appropriate file sets, copy them, and take them to a location where you have read and write permission. So yes, I have already copied them to a neutral location which I have complete permission, and I have put them over here for further analysis. Okay. So let me first get into thermal analysis. Let me first of all close the tutorial, maximize the screen so that you can see it clearly. So this is what it is. I'd like to have the image from tutorial for a moment, just to show you how the setup is. Okay. If I maximize this, okay. So you can see this, it is basically the orange part is a PCB board. Then it has multiple chips. So this is more for learning. Such chips have been placed at different locations. We are also using or taking the advantage of symmetry. So we'll analyze only 1/4 of this geometry. We will not take the complete geometry. Also get an understanding on how symmetry is treated in thermal analysis. So you can do that. And once that is done, that's ready to go. So this should give you a feel of what this particular component is. So you can see this is actually a 1/4 component with 4 chips on it. 4 chips. There is a base substrate material which is at the bottom, and how the setup looks. Actually, when you go into the top simulation bar, a new study, you have thermal analysis. You are selecting the thermal analysis. You can give a name and define the material for different chips. Okay, either from this database or is defined in SolidWorks, then it can actually import it directly over here. So all steps follow as per what we did in the previous lessons. So let's go into a study which I have created now and show you the different details that have been selected. So this CAD part, it has 4 chips. Okay, first thing, we have created a new study. It's in thermal analysis. First, check out the properties of this study. The default selection will be steady state. That is, we are getting the final result after attaining a steady state. That is what is happening, and we have this. If in this case SFE solver is used, that's fine. No changes required. So this is the basic thing. We follow this feature tree, by the way. Second thing that we'll be looking at is the material for these chips. All 4 chips. In this case, a custom material is used. In this tree, we'll also learn how to create custom material properties and apply them. And that is what has been done here. So when you get the custom material property folder, create a new library. You can create a new material inside it. Okay, what has been done here? You can appropriate values that you are aware of or from your database. Those all set over here. Okay, so what has been done here? The same material has been applied for 4 different chips. 4 different chips. Okay, and finally the base is of porcelain, and it is being taken from our ready-made database of SolidWorks. You have non-metals, and the ceramic material has been selected here. Okay, so this is about creating new study and defining the material properties. Contacts, no much change, it remains the default. The other important things would be the heat power, or each of the chips is going to create a certain amount of heat. We are setting those at the component level. Remember the selection, we are setting the component, not the surface, not the part, or not anything, but we are actually selecting the entire component, and we are selecting the per item. So each of these chips is going to generate a heat of 0.2 watts. That is happening. Okay, and yes, pretty much that's it. So we are saying all these 4 chips are producing a heat of 0.2 watts. For convection. Okay, so remember the image from tutorial. There are 2 surfaces. On the one at the bottom, will be subjected to probably atmospheric conditions. These three surfaces have been selected here, and what we discussed as coefficient of thermal convection, a value of around 25 has been given to these three surfaces. At your bulk temperature, it has been set to 300 Kelvin. Okay, so this is how the setup looks. Obviously, the question would be what happens to the other surfaces. The way it works, typically if other surfaces have no boundary condition, it just means that they are at a adiabatic condition. That is, no flows through them or comes into them. So it is absolutely adiabatic, produced by the different chips, and it is dissipated through convection through those three surfaces. So in symmetry, which we are treated here, is considered to be a surface where no heat property, and that's what is treated. This is the way it is treated in thermal analysis. This is looks. Finally, we see the temperature. You can see right after having a steady state, the central chip is comparatively hot, and it appears due to convection the other three chips are a bit lower temperature. Obviously, the selected has more exposure to atmosphere and can dissipate more amount of heat. So this is how it all looks. Okay, so that was a basic simple thermal steady state analysis. This can also be a transient. And the only difference over here could be the transient. If you see here in the properties, I am selecting the transient option. Select how much time I want to see the result. So in this case, I am seeing it for 900 seconds. Increment can be given, which is 30 here. So I am just telling the software save the results at every 30 seconds. So once I do the analysis, I can see the results at every 30 seconds. Okay. And apart from that, the only other difference here is the initial temperature. So willing what is the initial temperature of this entire setup. This setup would be under certain atmospheric or environmental conditions with all those parts and give something called as an initial temperature. That's it. No changes compared to steady state. We solve it, and on solving, if at a time which is 900 seconds, the risk could be absolutely similar to what you saw for a steady state analysis. But the important thing could be these graphs where you can see temperatures at different locations for a period of time. Okay, maybe I'll take the chip which is most at the highest temperature, which at node 1164. You can see at the bottom you get this response option. On selecting that, I can see a graph of temperature varying over a period of time. I can see the temperature is slowly increasing on this particular chip. Some at around 500 seconds, it readied down, and it maintains at that particular temperature of 380 Kelvin constantly. So typically, the state in this case could be attained somewhere around 500 seconds, and any further action can be taken after this. So independent variation of temperatures can be understood using this transient option. Finally, so stresses, I am typically creating a simple structural analysis. I create a static analysis. Only thing or the differences in the analysis would be, because this is a structural analysis, displacements are coming into picture. So I have to hold this particular part at different locations where it is hectically. I just restrict it at those locations. There are features and there are conditions. The thermal load comes from the thermal analysis that we have done just now. So in this, the temperature from a thermal study is being taken from this analysis that we did, from this transient analysis that we did. We specify the time step at which we want to take. So actually we saw after 100 or after 15 time steps, it could be adding a steady state, and adding that particular temperature distribution into the particular analysis. Finally, initial strain or zero strain condition is 300 Kelvin. That is, the plant starts at 300 Kelvin, wherein the strains are zero. Thereon, it is subjected to the temperatures which come from the transient analysis, And when the temperature is increased, we are seeing the increase in the length of the part. By the way of material, one of the most important material property over here could be coefficient of thermal the thermal expansion coefficient in the tune of 1 E minus 6 per Kelvin. So every Kelvin increase in temperature will lead to 1 E minus 6 increase in displacement strain. Okay, and on doing this particular simple thermal stress analysis, we'll see a lot of displacements in this particular part. So in a way, this part is trying to expand in the center. Actually, it has no space, and it may be actually even moving in a direction perpendicular to that, and it could be going up. That's what explains the creation of stresses. If the chips are connected to the porcelain material, the coefficient of convection could be quite different, and that can create comparatively larger amount of stresses and strains along that particular axis. Not many more things to be interpreted in this analysis, but moment this is what I'd like to highlight. Time in thermal, I might want to hurry up a bit in these two setups, but let's try to do maximum in this time. I have one more setup, the same from the tutorial. So I think it looks self-explanatory, where we have two bearings over here, and then there is a shaft. Okay, shaft which is rotating inside this bearing. Probably we don't know, but idea would be to ensure the rotation the shaft is rotating, the natural frequencies do not create any resonance in the particular setup. Typically, when you create a new setup, you should see this option of frequency. You are going to select that particular option. Okay, and material as well, as I told you, different parts with different material can be given. Sub is the fixture. The fixtures for the bearings, you can see here at the bottom, these two bearings have been selected at the bottommost surfaces here. Okay, and the connections between the shaft and the bearing can be no penetration. It is free rotated, but in this case, we are assuming that it is bonded. It is connected. Only difference is it is actually inside this particular shaft. Okay, solve it. In terms of results, the things that the software gives us using what is called as the frequency, which is in the tune of 3000 hertz, and the mode shape. If you observe this particular mode shape, it is deflecting in a lateral way, as you see on the screen. So this particular shaft rotates at a frequency of around 3000 to 3500 hertz. There is a possibility of it oscillating or creating resonance in the direction as that shown on the screen. So if I need to design this setup, I need to avoid this particular natural frequency, or I do further dynamic analysis to understand this in more detail. One is on optimization. I'm taking this knob example. Okay, now in the case, is taking results from different analysis. It could be anything, thermal, frequency, or a simple structural analysis. The simple setup for a knob, wherein we are saying it is fixed at certain location. A torque is applied on the outer surfaces over here, wherein we are trying to rotate the knob. Okay, and moments is a simple stress analysis. We do the deflection stresses. This is well, we have all understood it. What is new in simulation professional is something like this, wherein we can actually create something as a design study. Okay, design study. And you can see here we have different options. One of them is called as a variable. So I can create a new variable over here, or use existing one where I give a particular name. I can say particular dimension from the model. So this particular model is a parametric model with all the dimensions well defined. I can select any particular dimension down here, and this particular dimension can be used for optimization. What is the constraint and the goal? So constraint over here could be I do not want the factor of safety of this particular knob to fall below 2. and few goals. I want to reduce the overall weight of this particular knob. Let's have how the setup is created. So let me make this as big as possible. If you see here, variables, I have these 4 variables. One of the rib thickness. Okay, this one is the cut depth. The depth of the hole could be over here. The diameters and the height. So these are the variables which are varying between a certain range. We have different options of range with values, etc. We can decide what you want. Give it to the software. They are telling constraints. That is, in this case, as I told you, the factor of safety to maintain it or ensure that it does not fall below 2. Okay. So that has been told to the software. And finally, the goal. The mass of this particular object should minimize. I want to minimize the mass of this particular object. So on doing that, adding up the or solving this particular setup, I get something like this, wherein you can see all these iterations at different dimensions have been done by the software, and it comes up with a state which is called as the optimal state. So this is how the part would look with the optimal state. Let me in and show you the original state of this part. Let me go on a bit. Here it is. So the part was initially before we had design or the original design, which was given to the software for optimization, and it came up with this particular final dimensions, which were the optimized one. This did automatically. There are few different on the screen. I'm not sure if they are visible to you. One of them is in pink color, which is more saying that it does not meet the trends that have been given. A few other iterations which it has done, they can be selected and updated on the screen. Also iterations which are failed. So ultimately, once I do the final analysis, once I have the optimal one, I update it by selecting it and I'm ready to go. The model ready in SolidWorks CAD. I can directly create drawings out of this or whatever further processing. No import, no export, no data log. So it all looks, I think I overshot by only 1 minute and it should be all okay. Thanks for your time. This is what I wanted to cover today. As we do in the sessions, we'll take up questions now. Feel free to use the questions panel to ask questions. You see the polling window. Give your opinion on that. Whether you want a trial license or you want someone to come to with further discussion or any questions or feedback. So Q&A. While I browse through the questions. I'm just free to use the Q&A window. Let me check if this can be activated, because I want to show the way this particular solution goes on. Let me trigger the run option. Yeah, it's nice. Let's go through the Q&A panel while it is on. Okay, Q&A panel. Wow, mentions. I think dial question I should have answered you initially. Hope I should be able to see the polling window. Please give your choice. Hello. Yes, yeah. Sorry, someone complained that he cannot hear, so I just checked. I already have Premiere. Is the audio side going? I'm not hearing anything. I think these are like the links. So yeah, we'll try to keep a note of the Q&A panel. If you miss out, please drop an email to us on the link for the recordings. We'll share it with you. So the question is, I guess it is related to optimization, wherein we are asking, is it a design table? Yeah, almost similar to a design table. but it is far more intelligent than design table. Design table is restricted to manipulations which are driven by us. In this case, we are giving the bounds, that we are giving the minimum and the maximum stuff, and then software does the optimization for us. So as you see on the screen, actually the optimization is running, wherein it has decided the iterations that it wants to do. I am not giving these values, and it will optimize. So this algorithm is very intelligent. It can optimize as per your requirement. So I would say it uses the design table to do the further detailed analysis. Simulation, delamination of polyurethane from aluminum, that is station. So the question which may not be directly related to today's session, and which is more like this: can SOLIDWORKS simulate delamination of polyurethane from aluminum material? And he is more looking at adhesion. So if I put it in one line, we use something called as contact insulation, or it could also be a bonded contact as well. We can understand the shear stresses which are created at that location, or even the free body forces. So from either of these two, can understand whether the adhesion is strong enough to withstand those forces, or it is going to fail. So the process would be something like that, and I believe most of the software follow the same way, or RFA would use that particular method. In order to simulate the effect of thermal expansion between aluminum O-ring gland cutout, I want to know if the expansion of the aluminum will cause water leak. Yeah, the question whether we can simulate a combination of O-ring and the aluminum, probably the casing in which the O-ring is going to sit. Definitely, irrespective of the material, irrespective of the application, what you saw, these three broader level features are applicable, wherein you can simulate expansion, simulate temperature distribution, you can simulate time dependent behavior changes of temperature. Definitely you can do it. Can be used to simulate the stresses and deflection in sandwich composite panels. So yes, it can simulate composites. We do have a module of composite as well, but it simulates only layered composites. However, it depends on the thickness of the composite. If it is simulated as solid elements, you can have multiple solid layers and do it, or it would be multiple shell elements, both dull temperatures, and both can help you simulate composite. In terms of composite, it is a bit more involved field. Refrain from saying yes or no. Definitely, we might want to discuss it in more detail. Optimization be done on multi-body parts. Yes, so irrespective of the parts, that is either parts, assemblies, multi-bodies, or these typical standard scenarios which you see in SolidWorks CAD, or it could also be any of the analysis that you see in simulation. All those analysis can use this particular algorithm, or this algorithm can use any of those and simulate it for us. So there is a can SolidWorks do dynamic simulation? So answer is yes, and frankly one of the sessions which is going to come, I forgot when it is, but yeah, it is on 4th June. It would be on simulation premium and non-linear dynamic analysis. On this day we'll have a look at what we can do in simulation premium, especially on the dynamic analysis. If you are curious, one of the quick slides I can show you is this one, wherein you can see the different capabilities, and non-linear and dynamic would be somewhere in the premium model. So answers it can do, and we can handle it. Questions? Composites, it is coming in simulation premium. Frank had not planned any specific kind of training session, but if you are personally curious, please let us know. We'll try to have something for you. And an optimization solve for strength and minimum mass with a constraint on wall thickness variation. That is, wall section should not vary more than 20% within the part. Answers, I'll repeat this question, a bit long question. Can optimization solve for strength and minimal mass? So that is in this case wherein we are looking at minimal mass. In strength, it could be either factor of safety, or you can give some absolute stresses or directions to the software. Those can be seen as the constraints. And wall thickness is what you are looking at as a variable. We specify it. Now, obviously, there is no option to specify percentage, but you can specify the absolute values. That is, you can wall thickness is varying from 2 millimeters to 4 millimeters. So you can do it in that way. A good question which I did not cover today, which is on the material portal. How to access material web portal? Yes, it's a simulation professional capability, and it is, if at all you have the software, then you are getting this capacity wherein you can access the online portal. Check if I have it all going here. If yes, then I can quickly show you that. So into application of material, this material dialog box. At the left corner, you'll see something called as click here to access more materials, and that with a scanning wherein it is checking checking the authentication of your SOLIDWORKS serial number. You should be able to this site should come up, and it looks like this. So now I'm online. You are seeing this website. You select the kind of analysis that you want to do, and the appropriate material can be or the broader level segregation can be done, and it can locate the material from this particular database. So quick one, those who are not aware, Simulation Professional will come up with this particular set of material database, which is line, and it is coming from this company by name Materiality. This is available only for subscription customers, and you can actually get a huge database of material apart from what we are doing. And you can of course request for more materials over there as well, download and keep it for your records or sharing. So this is a thing inter offering with Simulation Professional, and no other software is providing it. Ultimately, you have to pay for acquiring this particular material. Okay, questions have slowed down, but let me recheck if I have missed out on any other questions, and I'll also slide which will show you the future webcast that we have, and hopefully the poll window is yet open. Please use it to give your feedback on your choice. Okay, how to access material? I'm very much in need of dynamic and nonlinear. Is it possible to have a personal training on these topics? Good. I think one of you is very curious about dynamic and nonlinear analysis. If you can drop us an email, we'll try to get our local partner connected to you and ensure you are comfortable with these modules. And can solid use for glass reinforced plastics? That's on 21st May, the session that I'm doing on SOLIDWORKS plastics, you will be, or at least I'll try to highlight on what we can do over there. And of course, it does have the capability to set glass reinforced plastics. You can density distribution of the fibers and how might be going inside the once it is injected. And if I missed out, please repaste your question so that I can see it again. And okay, this is directly do not have direct access to internet from my company intranet. I doubt if you can access directly Materiality. We don't have any login ID kind of stuff. It is going through your software and it is going through a software authentication only. So the other way out could be you can either borrow the license, or you can somehow take the license on your laptop and use it from your home, if at all you want to do it at home. Or if your company can own this site for you, that would be excellent. Yeah. So we are almost at the end. So with these 3 sessions coming soon, One of them is on 21st May, which is on plastics, solid plastics. I'll be highlighting more on this, more for plastic part designers. So you be designing plastic parts and you are just outsourcing the molding part of it. And as a part designer, you want to understand what all is relevant for you, whether part can be manufactured, whether there will be any manufacturing defects. You can get a feel of that. On 4th June, we are doing on the non-linear and dynamic stuff. 17th June, it would be more for mold designers using plastics premium. There we'll have a look at two interesting options. One of them is called as designing of cooling lines in mold, and finally warpage in plastic parts. Okay, these are what is planned in future. You should get the links in due course of time. If not, please keep note of these things. Questions, anything that we have missed out, please feel free to email us. I think the question stopped. That should be okay. Yeah. Thanks a lot, guys. Hope to see you in the next sessions. Hope Paul, you have given your opinion through the Paul windows, and thank you.